Hello everyone. Today we will discuss about magnetic effect of electric current. So let us concentrate on the activity 1 of your textbook. So what is the activity 1 of your textbook? A current carrying conductor is there, normal electric circuit, and a key is placed, and the current carrying conductor can be named XY, and near it a compass box is placed with its needle showing north-south direction, and the current is switched on. So what happens is that the current passes through the conductor XY. So this first experiment like this was done by Hans Christian Ørsted. So he noted that whenever a current was passed through this conductor and a compass needle placed near it showed a deflection. So he increased the current. So the deflection was more in that case. And when he switched off the current, there was no deflection. So what was the conclusion that Ørsted had made from it? The conclusion of this activity is that associated with every current carrying conductor, there is a magnetic field. So when a conductor starts carrying current, what happens is that there develops a magnetic field around it. This is of course called the magnetic effect of electric current. So what is the activity? We have to send a current through a conductor, and we can place a magnetic needle near it, magnetic compass box near it, and when the conductor starts carrying current, the compass placed near it shows a deflection. And when we increase the current, what happens is that the deflection also increases. And when we reverse the direction of the current, the deflection will be in the reverse direction also. When we switch off the current, there will be no deflection. So what will be the cause of it? We already have discussed that there is a magnetic field around the conductor. But why does the compass needle deflect? That's a question that is given in your textbook. You have to note that the compass needle itself is a magnet. So if this magnet is placed in the magnetic field produced by the conductor, this magnetic field will interact with the compass needle, which itself is a magnet. That's why the two magnetic fields interacting produces a deflection in the compass needle. I hope you have understood the concept. Now we go to the concept of magnetic field. So how will you define magnetic field? It is the region around the magnet where magnetic force is felt. So what do you mean by a magnetic field? It is a region around a magnet where the magnetic force is felt. There is an activity given in your textbook where a magnet is taken and some iron fillings are placed around it. So we can see in the diagram that the iron fillings get oriented in a particular direction due to this magnetic field. So iron filings are magnetic substances, and this magnetic field orients these iron filings in a particular pattern. So the existence of magnetic field around a magnet is shown by the orientation of iron filings around a magnet. So now we go to the properties of magnet. So the first property of magnet is the directive property. So what do you mean by directive property of a magnet? So directive property means when a magnet is freely suspended, it always orients in the north-south direction. That is what is meant by directive property. What do you mean by directive property of a magnet? When a magnet is freely suspended, it always aligns in the north-south direction. That is called the directive property. The second property of a magnet can be called the attractive property of a magnet. So what do you mean by attractive property? The magnet always attracts magnetic substances or any other magnet. So magnet can attract magnetic substances like iron filings, or it can attract another magnet. And the third property that you have already studied in your previous classes, like poles repel. Like poles repel, and unlike poles attract. So what is the third property? Like pole repel. So if there is a magnet like north and south, and another magnet is brought here, north and south, this north pole will repel. When south and south is brought, the south poles will repel. That is what you mean by the same pole. That is what is meant by the like pole. And unlike pole means if a north and a south, they will attract each other. Or south and north, they will attract each other. So the properties of a magnet, once again I am summing up. The directive property, that means when a magnet is freely suspended, it always aligns in the north-south direction. And the attractive property means a magnet attracts magnetic substances, or it can attract another magnet. And the third is like poles repel and unlike poles attract. This concept should be very clear before moving on to the next session of magnetic effect of electric current. Thank you.